Hi, this is the first presentation on gravitational fields, and we're going to start off with a couple of definitions that you'll need to know for the exam. First definition: what is a gravitational field? Well, any object with mass will create a force field around itself, such that if we placed a second mass in that field, it would be attracted towards the first object. The force field is called the gravitational field. Now, of course, if we had two masses in close proximity to each other, they would both be exerting attractive forces on each other because they will both be creating gravitational fields around themselves. The second definition that you'll need to know is gravitational field strength, denoted by the letter little g, which is the force per unit mass, in other words the force per kilogram, experienced by an object placed in a gravitational field. We can use lines to represent a gravitational field in a diagram. The arrows will show the direction of the force, and where the lines are closer together, the gravitational field strength will be stronger. A radial gravitational field is where the field lines are like spokes on a wheel. They are always directed towards the centre. In practice, every mass will create a radial gravitational field around itself. You should be able to see from the diagram, from the direction of the arrows, that the gravitational force is always an attractive force. Any mass placed within that gravitational field will be pulled towards the object creating it. You should also be able to see that the further you are from the object creating the gravitational field, the weaker the gravitational force will become, and the diagram shows this because the lines get further apart. A uniform field is where the gravitational field strength is the same in magnitude and direction everywhere in the field. If you're asked this question in an exam, it is important to say the same in magnitude and direction everywhere in the field. In practice, we don't get uniform fields, but it's useful for certain calculations to assume this. For example, the gravitational field around the Earth we know is a radial field, but if we are just moving short distances above the surface of the Earth, the radial field will change so little that we can say that it behaves approximately like a uniform field, and that's useful when we're doing calculations. And that's the end of part 1.
Created using Powtoon.